Hello, and thank you for your time. Today I'm going to be discussing an EDA we recently performed. We were given two data sets with specific information about beers and breweries and were asked to find meaningful insights from the data. We were specifically tasked to gain insights into the production of beer in each state, the alcohol content, international bitterness units, and how all of these relate. So let's get started. First, we wanted to look at the number of breweries per state, and we did this by counting up the total number of breweries in each state and plotting them here. We can see we have them ordered from greatest to least, with our top states being Colorado, California, Michigan, Oregon, and Texas. Next, we wanted to look at the missing values, and we saw that all of the missing data seemed to come from the beers dataset and not the breweries dataset. When looking into the beers dataset, we see that the majority of the values come from the IBU, and with the minimum number of values coming from ABV. We see that when looking at the ABV data that it's just a small proportion of the data that's missing out of the total data for ABV, although there's a much larger proportion of the total IBU data missing, getting close to 50%. Next, we wanted to look at the median ABV by state. And we did this again by ordering from greatest to least, the median ABV by state. And we see that DC, Kentucky, Michigan, New Mexico, and West Virginia have the top 5 median ABV. And we can also visualize that here by using a heat map where we can actually gain some more insights. Here we can see that Utah actually has the lowest ABV, with New Jersey also seemingly having a very low ABV, and our East Coast and West Coast seemingly having very high ABV. Our central states, there are some lower ABV values in here, but we can see some general trends using this plot. Next, we wanted to look at the median IBU by state, and we did a very similar plot here where we ranked from greatest to least the median IBU, and we see that our top 5 are Maine, West Virginia, Florida, Georgia, and Delaware. We made another heat map for median IBU by state, and here we can see that it's actually mostly the East Coast that have the highest median IBU, with the West Coast having some high median IBU values, and the central United States having the lowest median IBU values. Finally, we wanted to actually look at the highest ABV and IBU, not just looking at the median. And here we see that Colorado has the very highest ABV. And here we also see that Oregon has the very highest IBU. Something that we did make note of was that our top 5's ABV and IBU did not seem to overlap, which was fairly interesting to us. Next, we wanted to actually look specifically at the ABV distribution. And here we can see in a box plot where we have some outliers above our mean for our ABV distribution. This is evidence of a right skew distribution. And we can also look at the mean value being 0.05977 and our median value being 0.056, with our mean being greater than our median. This is also evidence of a right skew distribution, but we can visualize it in another way. Here we see a histogram where we have our ABV on our x-axis and our frequency on the y, and we can see there is evidence of a right skew distribution using this histogram, and a density plot can also visualize that very well. Next, we want to see the relationship between ABV and IBU, and we have ABV on our x-axis and IBU on our y-axis. There does appear to be evidence of a positive relationship between ABV and IBU, and something we did notice that there was a vast majority of the points were at 0.05 ABV and 25 IBU. It is important to note that just because you have a high ABV does not mean that you'll have a high IBU, because there are some points down here, but just as an overall trend, there does appear to be evidence of a positive relationship between ABV and IBU. Next, we wanted to see how much ABV and IBU contributed to a beer being classified as an ale or an IPA. We decided to use a KNN model to do this analysis, and basically this takes its nearest neighbor or data point to it and compares and tries to identify what it is. So here we can see with the K equal 1, we are going to potentially identify this as a class 1, but when we have a K equals 3, this would be identified as a class 2. We use this type of model in order to try to identify whether it would be considered an ale or an IPA. So we used our IBU and ABV as our test metrics with the K equal to 10, and our model was able to predict 144 times correctly that an ale was an ale and 20 times incorrectly that an ale was an IPA. It also incorrectly identified an IPA 18 times, but correctly identified IPA 85 times. We do see with our test metrics that accuracy is about 86%, sensitivity is about 88%, and specificity is about 83%. Our no information rate is about 61%, and with our accuracy having a much greater value than our no information rate, we can conclude that this model is a very accurate model. We also did want to test what the actual very best value for K was. So we did that by looping this test 100 times and testing 50 different values of K. And we found that a value of 6 was our best value of K. So here we changed our value of K to 6, and we saw an improved accuracy, specificity, and sensitivity. Next, we wanted to actually look at any interesting patterns in the data. So we decided to split this data up into different subgroups of beer and look at the IBU distribution. We see the IPA has the very highest IBU, it looks like, with ale and maybe stouts also having a high IBU, with amber, lager, and pilsner maybe having the lowest IBU. We also broke these up into the different kinds of beer for the ABV, and something very interesting was we actually saw a very similar trend to that data with the IBU. So if something is very high in the IBU data, it seems to be very high in the ABV data, just like the stout and the IPA, or low with the amber, the lager, and the pilsner. We also visualize this by using scatter plots where we have ABV on the x-axis and IBU on the y-axis. There appears for all of these different subgroups of beer to be a positive relationship between ABV and IBU, although amber does not appear to have that relationship, although more data points might make it a little bit easier to identify that relationship in amber. Finally, we conclude that we do see evidence of a positive relationship between ABV and IBU, and when I was examining subgroups of beer, that the distributions of ABV and IBU are very similar whenever examining them together. So this is a lot of what we have found in our data, and we appreciate your time, and we hope to work with you again. Thank you very much.